Hi, I'm Shintu. I'm a biotechnology student. Have choose to talk about thermodynamics. There are four thermodynamic laws. Let's see how these thermodynamics laws are applicable in biotechnology studies. The first and second law of thermodynamics apply to enzyme-catalyzed reactions. The first law is demonstrated in photosynthesis, where plants convert sunlight into chemical energy. Enzymes lower activation energy, speeding up biochemical processes. The second law involving entropy explains how enzyme accelerates reaction without altering free energy. The second law of thermodynamics explains the membrane transport. Passive transport increases the entropy as molecules move spontaneously up to the concentration gradient with negative free energy without ATP, while active transport decreases entropy locally, requiring ATP to move molecule from low to high concentration by making the overall free energy negative.
Hi, I'm Navina Goindraju. I'm biotechnology student. I chose topic thermal physics and my subtopic is temperature. So in this case, I will relate to autoclave in biotechnology. Application of temperature in biotechnology. Autoclave is a device in biotechnology used to sterile equipments and materials by exposing them to high temperature such as 121 degrees Celsius. This process is to eliminate or denature microorganisms such as bacteria, virus, and spores. So how temperature is utilized? Autoclave operate at temperature of 121 degrees Celsius to 134 degrees Celsius. These high temperatures denature proteins and disrupts cellular structures of microorganisms. So why it is important? It is because can prevent contamination by pathogens in sensitive biological experiments such as petri dish. Next is to ensure that any infectious agents on lab materials are neutralized, and precise temperature monitoring guarantees reproducibility and safety in research and production processes. For example, in antibiotic testing, sterilized petri dishes ensure only the targeted bacteria grow, providing accurate results. Without sterilization, contamination could ruin the whole experiment, making autoclave indispensable for reliable research and clean lab conditions. That's all from me. Thank you.
Hi, my name is Roy. Now we will look to the rotational motion. It is the movement of a spinning object on a fixed axis. Rotational motion is different to translational motion. There are a few components in these motions, which are angular displacement, angular velocity, and angular acceleration. But in this topic, we will focus on centripetal motion. It is the movement of an object in circular path driven by a force directed toward the center of the circle, which is called a centripetal force. An example of this motion is a rider riding a merry-go-round at amusement park. Alright, now we can relate rotational motion to biotechnology by looking at the centrifuge machine. The content inside the microcentrifuge tube will move in circular path as the machine spins. Centripetal force will help to maintain its circular motion. Here, the denser particle will be affected more by centrifugal effect and outward push. Hence, denser particle will be settled at the bottom of the tube. Moreover, denser particle will also have more inertia due to its higher mass. Hence, it resists the centripetal force more effectively. That's all from me. Thank you.
Assalamualaikum and hi. My name is Yusrina binti Yusufu. My number matrix is BS231100165, and today I'm gonna present a title name Solid and Fluid. Okay, first the basic one. How many states of matter? We have four states of matter, which is solid, liquid, gas, and plasma. And the question is, how does this relate to mathematics with computer graphic, which is my course? The state of matters can relate to my course by helping create realistic simulation and visualization of how this material behave. Let's see. As you can see, solid and fluid have many influence the application in MCG. There are so many that I can pick, but I choose to pick the fluid rigid bodies. In fluid dynamic simulation, rigid body concepts are applied to model how solid object is interact with fluids, like boat floating or sinking, or the picture that I've shown you. It's like the car, which is solid, is interact with the water, which is liquid. Physics engines and software like Blender, Unity, use this principle to calculate realistic motions and render the interaction between fluids and rigid bodies. Last but not least, this is the example of an animation that involve buoyancy, fluid pressure and depth, viscosity and resistance, surface tension, conservation of laws, and equation of continuity. That's all from me. Thank you.